Hello, ladies and gentlemen. Hello, and welcome back. In this video, we're going to look at question number 12 on our 2011-2012 Alberta Math Contest, Part 1. The sum of 20 positive integers, not necessarily different, is 462. The largest possible value of the greatest common divisor of these numbers is... Okay, the GCD of 20 numbers. So how can we approach this? These are all actually pretty big. I would have expected, it's an even, so maybe you can make it the sum of all even numbers, but I guess maybe there are bigger things. It's not like there's a none of these or a not uniquely determined or anything like that here, so it's got to be one of these answers. That's interesting. So let's think about it. If I've got some numbers, A, B, and C, and they all have a GCD of, let's say, little d, then I can write A as little a times d, B could be little b times d. This is if d is a factor of all of these, which is what it means to be a divisor, or a common divisor, then I can write each of these as an integer times d. Okay? And so if you add all those up, the sum is also a multiple of d. So these possible divisors, the greatest possible divisor that we're looking at in this question, has to be a factor of the sum of our 20 numbers. I only have 3 numbers here, but it's got to be a factor of the sum of our 20 numbers, 462. So what are the factors of 462? Well, you divide by 2, and that'll be 231. Divide that by 3, and that'll be 77. So we get 3, 7, and 11. So we can actually start listing out possible factors. And we're not that concerned with them, with all listing out all possibilities. There should be 16 of them, because we're really only concerned with the ones that we have presented. 42, well, that's 2 times 3 times 7. 33, that's 3 times 11. That's definitely a factor. 23, that's out. That's not possible, because 462 doesn't have any factors of 23. 22, yeah, that's 2 times 11, that's a factor, and 3 times 7 there as well. Okay, so we've eliminated C. C can't possibly be it. But I still have only 4 possibilities. This is not enough to guess with. If we eliminated it down to 3, maybe 3, but definitely 2, then yeah, you could take a guess if you were running out of time. But, all right, well, what can we do? Well, we know each of these numbers here is positive. So when we add up our numbers, there'll be 20 of them, and the 20th letter of the alphabet is T. We get 462, right? But if whatever number D we've got is a common divisor of all of these, then, this is AD, this is BD. These numbers here have to be at least D. So you are at least adding up 20 copies of D. So what we've got here is 462 has to be bigger than or equal to 20 copies of our divisor. All right, if we divide both sides by, divide both sides by 2, you'll get the 231 we had earlier. Divide both sides by 10, you know that our D, our greatest common divisor that these numbers could have, could be no more than 23.1. And I suspect that's why they had C here, in case you just knee-jerk reaction said, okay, the biggest integer less than that is 23. It looks like the answer should be 22, because that is a factor of 462. It is less than this bare minimum of 23.1, so it should work. The only question is, can we actually make it work? Right? The answer should be B22, but let's quickly check. If I have most of these numbers, let's say 19 of these numbers be 22, then what are you going to have? 2 times 19 is 38. 38 times 11, 38, 8, 1, 1, 418. And then what's left to get 462? 44. So have your 20th number be 44, and you're good to go. Right? That should be it. So yeah, that does work, and so the answer is B. The greatest common divisor is 22. Okay? Not that you couldn't pick 20 numbers that had 21 as their GCD, or 7 or anything like that, but the biggest you can get is this 22. All right. So that does it for question number 12. Up next, we're going to take a look at question number 13. Feel free to give it a try if you haven't already. Just a quick reminder, you can get a copy of this contest by following the very first link in the description. It takes you to the AHSMC homepage, and on the side there, you can see all the nice little question and solution archive. Okay, so give question 13 a try, and I will see you guys next time.